Alright, so 24, it is helpful now that we're starting with complex numbers to remember that 3i we can write as 0 plus 3i, and we do have some like formula thingies to help us figure out what r and theta are for trigonometric form, and on your unit circle you have written down what trigonometric form is. It's r cosine, r parentheses cosine theta plus I sine theta, close parentheses. So the r here is the radius, and you do 0 squared plus 3 squared, which is square root of 9, which is 3. That's what r is. And then when we try to do the inverse tangent of b over a to figure out what the angle is, we run into a problem, which is why almost no matter what, I would say, it is really helpful to graph this in the complex plane. Remember, this is our real axis and this is our imaginary axis, and so 3i does not go anywhere on the real axis, it just goes up 3. So if we had originally just graphed it, we would know, hey, it's 3 from 0, 0. So we would have known r is 3, but now also, check it out, we know that this angle is 90 degrees or pi over 2, which the calculator could not have told us. We might have gotten there from our unit circle, but it is important to realize that connection. We're literally finding that angle. And look, there it is. It's pi over 2. So to write this in trig form, we put 3 cosine pi over 2 plus I sine pi over 2, close parentheses, box it. There you go. Now 25 asks us to go the other direction. Write the complex number in the form a plus bi. So we need to distribute the square root of 6 into our parentheses, but notice that 315 is on our unit circle. So we actually would like to go to 315 on our unit circle over there in the fourth quadrant and write down those values for cosine and sine. Cosine is square root of 2 over 2. Sine is negative square root of 2 over 2. And then let's distribute the 6. If we distribute the 6, that multiplies with the square root of 2 to get square root of 12 over 2. This minus will come in front to make it subtraction. Square root of 12 over 2i. Now this actually will simplify some. Remember that the square root of 12 has 4 times 3 in it. We can take the square root of 4, which means that this is 2 square roots of 3 over 2 minus 2 square roots of 3 over 2i. And those 2's will cancel, leaving us with the square root of 3 minus the square root of 3i. Remember that those are not like terms. We can't add those together or try to say this cancels out and is just 0. That doesn't even make sense for what we have, what we started with, to just end up being 0. So remember that. Those are not like terms. Sorry. Okay. Product and quotient we have some formulas for. They start off in trig form, that's helpful. We want to leave them in trig form, even more helpful. So for the product, you simply take the r's, which are the numbers in front of our parenthesis, you multiply them together, and then you take the angles and add them together. Okay. I'm just going to put dot dot dot. Well, actually, instead of putting dot 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 there, I can actually get some common denominators here, right? Because we need 12 on bottom, so that gives us 9 pi over 12 plus 20 pi over 12, which would be 29 pi over 12. So this is 9 times 3 is 27, cosine 29 pi over 12 plus I sine 29 pi over 12. That right there is the answer on that one. On number 27, we're finding the quotient, and so you put 8 over 5 and then you subtract the angles. So 180 minus 50 is 130. And we're leaving it in trig form, so that's our answer. Easy peasy. Alright, so de Moivre's theorem is a formula on our unit circle card, and we are trying to find the this complex number to the third power. So that's the n in our formula is n equals 3. So what we do is we take r and we put it to that power, the r to the third power, and then we in our formula have cosine n theta plus I sine n theta. So we are taking the angle pi over 2 and multiplying it by our n, which is 3, giving us 3 pi over 2. Now this asks us, if we look at our instructions, to write the answer in standard form. 3 pi over 2 is on our unit circle down there at the bottom. 5 cubed is 125. So cosine of 3 pi over 2 is 0, and sine 3 pi over 2 is negative 1. So if we look at this, this actually ends up being just negative 125i. Because the first part of it is 0, but we put the 125 right here with the negative and the I, and that's what it becomes.